Hey guys, this is JSer. How's everything going? In this video, I'm going to take a look at 1031, maximum sum of two non-overlapping subarrays. Given an array, we need to return maximum sum of elements in two non-overlapping contiguous subarrays, which have length L and M, and then get the maximum sum of them. So if suppose we have an array like this, we need to return one element and two elements. So we could choose 9 and 6, 5. So we got 20. For this, we turn 3, 8, 1 and 8, 9. So we got 29. Yeah, so how should we do it? Well, so let's first analyze how could we solve this when there is only one. When what? For one subarray with specific length. Well, suppose we are going to return length of 2, and the maximum sum would be just use sliding window, right? Sliding window to get the max sum, right? So this is on, we go n. So for 2, there will be two subarrays. We suppose if we have fixed the left array, the subarray here, then we need to get the maximum among the rest, right? If you choose the subarray in the middle, we need to get the maximum to the left and to the right. And if we move the subarray along this array from left to right, it means we need to get the maximum from left to right and get the maximum from left to get the maximum for the head and for the tail. But when we are moving along to it, the leftist max could be derived while we are looping through it, but the max to the right is not, right? We need to pre-calculate the maximum from right to left. Well, cool. So the idea is simple. Loop through the A for size L. For each, we need to get the max get max of M at the head, and get max of the maximum of M at the rear, right? This needs to be pre-calculated. So yeah, so that's it. Let's first get the pre-calculated sum M at the rear. Maximum of M elements, okay? Cool. So let's do it. So this is max M star from. Okay. So the index should be I from. This is length minus 1, so this is n minus 2. So this is 2 elements. So I start from a dot length minus m. I should be bigger than equal to 0. So we move the start index from right to left, right? So let current max minus infinity no, I made a mistake. We should I from the length 1. Let current sum equals to 0. If we only update the maximum array when there is enough element, right? So we sum plus with AI. Yeah, and then if I is smaller or equal to a.length minus m, we the maximum, right? So let current max minus infinity. So current max equals math max current max current sum, and we update the array. Max m start from I equals current max. So we get the data here. So now we need to do process L. Cool. Okay. So we need to also keep track of the maximum of m and the sum of L, right? Cool. So there will be let current sum L 0 and let current sum m 0. Let current max m minus negative infinity. And now we loop through it. Let's start from left to I plus L element, one element itself, so L minus 1. This is the last index. Which is smaller than a.length. Okay. So we update the sum. I made a mistake. This is a problem. If this is it, we get this sum, and then after we get the max, we need to remove the previous one. Yeah, I made a mistake. This is it. So if I is smaller than a.length minus m, this is sliding window. So current sum should be subtracted with AI plus m. Right? If there's one element, this is the current sum. Right? This is the current this is the right current sum. Cool. So we need to do the same to the m from left. We plus with AI, and if I is bigger than m minus 1, we need to current sum m subtracted with AI. I is the target. This is end at. This is start from. So end at, it should be, if it is one element, then it should be previous one. So I minus m is 2. Yeah, I minus 1. Cool. So this is we get the current sum m, and what we do, we just get the maximum, right? So current max m would be math max and the current sum m. Okay, and also we need to get the max sum minus infinity. So we get the maximum from left. And we also, there's a problem. We get the maximum here. We need to actually keep track of the maximum because the m, suppose the L is like this string, we need to get the maximum here. I see. So actually we need to keep track of that also. Okay. Here, let's use say const max m n at. Cool. Now basically it's the same. If it is this bigger than it, then we update it to the right sum, and if I is bigger or equal to, oh, what happened? Excuse me. Oh. Oh. Uh-oh. Uh-oh. Shit. Something wrong about my keyboard? I didn't modify any code, right? Oh, here. Okay. And bigger than it, we actually need to update the current max. And then update the array, which is current max m end at. Max end at I equals current max m. Yeah, this is it. And by the same time, we need to calculate the sum of L also. So calculate the sum for L. We do the same. Current sum L plus equals AI. I is bigger than L minus 1. We current sum L, subtract with A, I subtracted with L. And this is the sum. So this is the update, the final max sum. So here is the most exciting part. Max sum should be max sum. Oh, max sum with. Okay, it seems like my keyboard doesn't have any batteries. Wait a second. Okay, now it has the power. Okay, for I, we should, like for L, like substitution here, we need to get the max from left, ending at here, ending at this, right? So we get current max end at, what is it? It should be I subtract L. Right? If I is one element, then it's plural. Yeah, this is right. And plus current sum L plus max and start from I plus 1, right? So the maximum sum will be updated with a second sliding window, and finally we could return the max sum. Allow me to review this code one more time before I try run the code. We keep the start from array to keep track of the maximum sum for m. We loop through from right to left. I found the start from. So yeah, start from, yeah, this should start from 0, and then calculate its current sum. If it is longer than the m, we subtract the element and to the right. This is to get the right sum. and we start updating the current max and cache it to this array. Cool. And now we are doing the same to cache the sum for m, which is ends at. Update I. This looks good. And then we do the same to calculate the sum for L. Yeah. So here's a problem. I found that if we only update the I. We only update the I here. Right? Yeah. This. And there is a problem actually. This might be negative, so this will be undefined. So I'll say const max m max left, okay, max sum m left, like head. Okay. From left equals, if I minus L smaller than 0, then it should be 0. If not, it should be this. And const max m from right, I plus 1 is smaller than a.net, then we should use it. If not, we should set it to 0. Cool. So now we handle the boundary, and finally we could just return the max sum. Let's write on code. Sad. We got not a number. So yeah, let's log the array. Well, it's right, and let's log this. 0 is I made a mistake. Yeah, it's not actually smaller than 0. It should be set. It should be this is the key. If it is smaller than m minus 1, then it should be 0, right? And again, if from right, if I plus 1, like plus m and minus 1. If it is, this is a start and this is the end, right? Yeah, if the end, yeah, this should be right. Oh, we'll get something larger. Really? We getting this wrong. Let's see. So we are getting let's log the current sum L a slice I minus L plus 1 I plus 1, and get the maximum from left, maximum from right. We run the code. Okay, we now handle 6, 5, L is 1, so I think I made a mistake here. We need to... Oh, this is right. Ah, yeah. Huh? Okay. For 6. For 6, current sum is 6, and this 0, and this is 16, 13. We're getting it right. And for 2, we get 11 and 13, so 20. BL. Ah! I know what happened. It should be gets either, not both. Shit. God. Max. But I found some problem. I is bigger than this one. If they equal to this, then we still could calculate the sum, right? So I think I've made a mistake here. Current sum, I'll say if I is bigger than or equal to I minus 1, I can do the update. Yeah, oh, nice. Looks great. Oh, come on. Ah. What? Return. I did this like 1 year ago. This is what I did. Wow, it's very concise. Oh, did I write it? Anyway, so this solution actually, the logic here actually could be moved into a function, right? And let's see what happened here. We got it minus infinity. What? 10. 1, 6, 9, 10. So I think we should current sum plus maximum this. So for a slice a minus L plus 1 I plus 1. Max sum left, max sum right, current sum L. Let's see what happens. Infinity. There's no 0, 1, 2, 3. Shit. I means the end. I mean, right. Yeah. Ugh. Stupid. I am stupid. Okay. These looping conditions just makes my brain miserable. Okay, come on. Yeah, okay, finally we did it. But the code, I think we could make it better. Like separate them into a function, right? like something, okay, like this, and const max. No, it should be sum L and constant max m in that, and then we created a separate function, and finally we will move through all the index find, get the sum L, and just to calculate. So the for loop for this one could be much conciser. Yeah, and let's analyze the time and space. Time. This is linear. This is linear. Yeah, so linear time. Space. We use 1, 2 array to hold the temporary maximum. So it's linear space. Cool. So that's all for this one. Hope it helps. See you next time. Bye bye.